So continuing on with day 3 notes, we're at example 5. This is about inverse relations and inverse functions. So an inverse relation is switching the input x values and the output y values of the original relation. Key word I would say here would be switching. Switching x values and y values. Okay? The inverse function, both the original relation and the inverse relation are functions. So both original and inverse relation are functions. So how can we determine that? Well, you already learned about the vertical line test, but now let's look at the horizontal line test, which you only really learn when you get to Algebra 2. So here, if I were to draw a vertical line, we're just going to use my ID here for a second. So we draw, a horizontal line. Okay, so I drew a horizontal line, and I want to see how many times does my teal line here cross that graph of a parabola, the U-shaped graph. So I see it touches it here, and it touches it here. So it touches 2 times, right? Well, if it touches 2 or more times, it will not be a function for the inverse. So no. Here, I check it out. It only touches it 1 time. 1 time. If I drew it again, you can see it's only going to touch it 1 time. So that graph touched my horizontal line 1 time. If it's 1 time only, then yes, it would be a function when I do the inverse. So how do we do the inverse? Right? That leads us to example 6. At the very top, this is just a chart for you to basically see the original versus the inverse. And you can see, very simple, for ordered pairs and table of values, you're just switching x and y. So here's your original, 1, 3. You just switch that to be 3, 1. Then it becomes 2, negative 4. Okay, so, and then if it's the same numbers, it's going to be the same thing for the inverse. Now, given an equation, a little bit different. We have to, well, actually, you know what we'll do? Let's just do A and B to match this, and then we'll go back to this one. So for this one, what I would do is I would just rewrite this, x, y. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So now, if you're switching them, the y becomes the x. So my y at 3 is now the x. The 5 is now the x. 7, then 9, then 11. Then I need to move these to the y. So 3, negative 2, 5, negative 1, 7, 0, 9, 1, 11, 2. Okay, same thing here. We're just going to switch it around. All right, so we've got 5 again. Again, same thing. Make those y's now an x, and make the x a y. All right, so we're just switching. All right, for the next part, given an equation. So for this one, first is replace f of x with y. Okay, so this becomes y. The directions at the top say interchange x and y. So now my x is where the y was, and my y is where the x was. Step 3 says solve for y. Okay, so the first thing I need to do to solve for y is to add the 5 over. So x plus 5 equals 2y squared. Still don't have y by itself, so I divide by 2. And this gives me x plus 5 divided by 2 equals y squared. Now, if you remember, to get rid of a square or an exponent, you have to square root both sides, and that cancels out the square root and the 2. And you square root this side. So now, since I square rooted this portion or this term, this cancels, and I've got y equals the square root of x plus 5 over 2. So in letter D, we're following the same steps. Oh, you know what? Go back to step 4 real quick. The y, you're going to replace it with f negative 1x, which means inverse. Okay, here we go. Letter D. Take the f of x, make it the y. Then switch your x and your y. Okay? Now, in this problem, I have a fraction. And if I want y by itself, I got to get rid of 1/27 first. So I'm going to multiply both sides by 27. So this gives me 27 times x. These cancel out. I'm left with 1y cubed, but I don't need the 1 there. Now, this is very similar to this one as far as the square root goes. This 3 means that you're going to take the cubed root. There's actually a tiny little 3 right here, like this. And these cancel. Remember to replace this with f inverse x. Okay, now, the cube root of 27x. We can actually simplify that a little more. And I'm not sure, like, if you guys have learned factor trees, I'm sure you have. But to figure out the cubed root here, if I break down 27, I know that I have 3 3's. When it has a 3 here, that means you're finding groups of 3 numbers. So here I've got a group of 3, right? Well, that goes on the outside of the cubed root as a big number. Then if there's anything left over, you keep it inside of the radical. So in this case, if your problem has this cubed root of 27x, this x has no group of 3 x's. So it's left over. It goes back in. So we would have the cubed root, nope. You would have 3 times the cube root of x, because we could simplify that 27. Okay, last problems here. Given a graph, it says reflect the original function over the line y equals x. So here's your y equals x. Remember that y equals mx plus b. So this would be, slope is 1, or 1 over 1, and you start at the y-intercept at 0. So over here, I'm going to start at 0. Let me use a different colored pen. Okay. So at 0, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, keep going. And I have created y equals x. So now that I have my y equals x drawn, I'm basically going to plot these points directly to the other side. Okay? So the easiest way I find to do this is if I write down the ordered pairs. So this would be 0, negative 3, 1, negative 2, 2, negative 1, and then 3, 0. I know that from the first example on this page, you can just flip these, right? Switch your x and your y's. So to switch them, I just rewrite them, switched, and then you're graphing those. So at negative 3, 0, at negative 2, 1, at negative 1, 2, and 0, 3, you have your new graph. And you could think of it like if you folded your paper on that dotted line right there, you know, this point has to match to this point. This point has to match to this point. They would all match up. All right, last problem. Let's go ahead and graph y equals x. So you're starting at 0. You're going up 1, right 1. We're also going down 1, left 1. Okay, draw your dashed line. Okay, the 3 points that were given to me, I'm going to go ahead and write those ordered pairs. So I've got negative 1, 0, which becomes 0, negative 1, 0, 1, becomes 1, 0, and lastly, 3, 2, becomes 2, 3. So graph those. So 0, negative 1, 1, 0, and 2, 3. Okay. All right, so that is it for inverse functions.